So today we're going to be talking about comparing moving costs. So for our first example, Jay is moving from an apartment in Miami to one in Orlando. If Jay moves on a weekday, he will need more movers, so time to pack, load, unload, and unpack because his friends will not be able to help him. If he moves on the weekend, then he can actually get his friends to help him, so cutting down on the number of hours he will need to hire movers. So the Move Out is a company that is supplies the. So the Move Out company that will actually provide movers, trucks, and moving equipment. So they give him these actually different quotes for the weekdays are here, and then his weekend, if he moved on the weekend, it's here. So for the weekday, it's 6 hours of loading and unloading, 5 hours of packing and unpacking, and that would cost $720. For the weekend, it'd be 4 hours of loading and unloading, 2 hours of packing and unpacking, so they're saying it will cost $400. So Move Out charges a set hourly moving team rate for loading and unloading, and a different set hourly team rate for packing and unpacking. So we're going to determine the Move Out hourly rates. So we are going to use the equations of those values. So if we have the weekday, this is the formula that we will be using. So his weekday formula for moving on the weekdays would be 6x for unpacking, packing, and 5y for it says right here, for the hours. So 6 hours was for loading, unloading, and then the 5 hours was for unpacking and packing. And then we had the $720. That's how much it's going to cost. If it was on the weekend when they were moving, then the formula, if we look back, it actually cost 4 hours for loading and unloading, or they allowed 4 hours, so that's going to be our x variable. And then it was 2 hours for the unpacking and packing, and it only cost $400. So now, we just got done learning how to do 3 different methods by solving our systems of equations. The reason why I know I have systems of equations is because I have 2 equations here, and they have both x and y variables. So now, what I'm going to do is we're going to either use substitution, elimination, or graphing. And we are going to use those methods in order to actually go through. So I don't have a variable actually go through and solve this system. So I don't have a variable actually solve for. So I can either use the system by substitution or elimination. So I'm going to go ahead and do the elimination method. So when I get the elimination method, I need to figure out a coefficient that is going to be, I can multiply this entire equation by those values to get the same coefficients to try and eliminate a variable. I'm going to work with my y's just because I want to multiply this one by 2 and then this one by 5. Oops, to get 10. I already gave you the answer. Okay, so now I'm going to distribute. I'm going to rewrite these equations. So I have 12x plus 10y, and then we need to do the 720 times 2, 1,440. And then now I'm going to distribute this 5 to all of those variables. So 5 times 4 is 20x, 5 times 2. Oh, and we have to make one of them negative so that they actually subtract from each other, so we make that a negative 20. And then we have a negative, let me actually erase this. Then we have a negative 10y, and then if we did our 400 times the negative 5, we end up getting negative 2,000. Okay, so now that I have my coefficients here that actually do match and they're the opposite signs, they will subtract out. So now I have 12x minus 20x, which leaves me with a negative 8x. These cancel out, and then I am left with, let's just double check this, negative 560. And then we are going to divide that by 8 now to get x by itself, a negative 8. A negative divided by a negative is a positive, so now I have a positive 70. Okay, so that's 70. And then now I'm going to finish by substituting in that x equals 70 into one of my equations. I'm just going to plug it into the second one right here. So I have 4 times 70 plus 2y equals 400. Now I'm going to go ahead and do 70 times my 4, and I get 280. plus 2y. And now I'm going to go ahead and subtract 280. And now I have 2y equals 120. We divide that by 2, and we get y equals 60. All right, so what it actually wanted us to figure out was the rate for the hourly rate for loading and unloading. So the loading and unloading variables, if we look back here, this is the one we represented as our x, this is the one we represented as our y. So our loading and unloading right here was our $70. So if we have, this would be our actual solution like this, you guys, 70, 60. So for our x, we have $70 per hour for loading and unloading. That's their hourly rate. And then we have our $60 for packing and unpacking. I'm going to squeeze this in over here. So we have $60 for packing and unpacking. So that's how you determine their hourly rate, so then we know how much they are charging us. All right, you guys, so you guys can use substitution elimination for these. I want you guys to go ahead and try setting up your equations for this problem, and we will go over them in class.